And then we traverse further into the next compartment. So from lecture, you would call this 3 letters. The LGJ right there, gastroesophageal junction, where you've got that zone telling you it's esophagus right there, stratified squamous. And then you see how abruptly it changes. And now you've got the cardia of the stomach, where you know it's attached. And if you really magnified on this, you'd see just a little layer of stratified columnar in some specimens. You can see that, you go, oh, you got Barrett's esophagus mentioned in lecture on Monday. It's just a little cellular feature that you find in some individuals where it transitions and now can be somewhat unstable for mitosis. I was just amused to have someone bring up this little transition for seeing that in some individuals. But here the transition is just sharp. Go directly from stratified squamous, simple columnar. And then you note it's pitted. You get this pitted appearance typical of gastric mucosa. We'll concentrate on the fundus and the body. Don't worry about the cardia or the pyloric end. And most only need this rugged look on the surface to tell that this is gastric histology. Pinholes, gastric pits at the top, gives it that rugged look. And then you can zone the various cells. The ones you'll find in the pit, more mucus cells, see that in a moment. And then a little lower down, more orange to reddish, parietal cells dominating this upper zone. And then as you go deeper, it turns more bluish, this area. So now you have chief cells dominating. So I call it the zonal histological difference. Parietal is going to predominantly chief. You still should be able to get right into a gland and singularly identify the 3 cell types. So kick it up 150x. See the pits nicely, dominated by these clear cells. Mucus cells, higher up, putting out the alkaline mucus of the GMB. You can see the difference in the epithelial type for the stomach, which is simple columnar. All the purple dots are the basal nuclei of those cells. And then down you go into the gastric glands, millions and millions of them, showing singularly this cell, perfect example of a parietal cell. And then as you go down, start to see the bluer ones. So if we go a little deeper, magnify a little bit more, we can see the clustering of those blue cells. Once again, it's the cytoplasm that you're looking at for color. So you would know those as chief cells. Quite obvious. But you can also see parietals and even these. What are those? Mucus. So don't ever think that you won't find mucus cells anywhere in a gastric gland. It just tends to be dominant higher up. But even deeper down in the gland, you can see the 3 dominant cell types, with chief, parietal, mucus. All right, so those are the three I want you to be able to identify. Okay, then on we go through the pyloric sphincter into the small bowel, most noted by the little fingers that you see sticking up into the lumen. So the villi instantly tell you you're in the small intestine. You should also be able to identify the little glandular pockets at the base of the villi, crypts or intestinal glands, starting to show these little bubbles. Mucus cells? No way. Gotta be goblets, right? And those little bubbles are goblet cell openings. And the beginning of that cell type, which gets ever more numerous every inch, going down through the intestines. And then you'll note here there are glandular pockets underneath the crypts. So the crypts are here at the base of the villi. You go into the submucosa, and now you've got other glandular pockets, really mucus cell clustering down here. And then you really should know the eponymic name for those clusters. Brunner's glands here. And we just say, you see Brunner's glands. Well, you first know it's small bowel with the villi, and you see Brunner's. Gotta be duodenum. Brunner's always adds up to duodenum. And you get other examples here. Nice specimen showing the villi. Nice crypts going down here. But then I wanted you to be able to interpret what these would be called. These circles. They're the same. And that it's a 3D interpretation, knowing it had depth, and that a crypt goes straight down and then it turns 90 degrees once it hits the submucosal interface right there. It's like it can't go into the submucosa, so it's got to pull up and turn. And so now you have this inverted cane, or this L shape. So these are crypts, just like these. And then underneath, mucus cells, Brunner's glands, once again. Another section of duodenum. A little harder to see those little holes, the bubbles, but still goblet cells. You see them much, much better as you go farther down in the intestines. And then we can put it all together. Here you've got the muscularis externa of the entire intestinal wall. Right there. You got serosa outside of it. Right there. But luminally, you go around and you say, oh, here are the little fingers. So you got nice villi sticking up there. But you also have these hills, one degree or another, called plicae. And a big mistake is to think this is a villus, one of the villi. Much too big. I say this is a hill, these are the trees, this is the villi. You shouldn't get that size difference confused. You can also see all the crypts all the way around, all the intestinal glands, and then deeper underneath, little glandular pockets as well. Brunner's glands, all the way around. So this is duodenum, just a complete circumferential section of duodenum. If you're really a histology savant, you might know what this is. Don't worry about it. You really have to have a great sense of histo relative to gross to know what that has to be. If this is duodenum, this is a tissue that's tucked right into it. Caught it, just the edge of it in the section. What's tucked into it? This is pancreas. Remember, pancreas tucked right into the inside curvature. Just caught the edge of the pancreas. But you will never need to know that for this presentation. So you're a histogenius. You could make that association without someone telling you. And then last, I would have a vague general sense of what truly plicae are for, just to be more advanced than the typical A&P2 lab student. And that if you're standing in the small bowel looking at these, or down at your feet, these little folds going circularly around the lumen. So most will tell you these are for surface area, but you know better. What do? They mix the chyme with the slurry coming in from the stomach, so that now it goes up and turns over and over as it goes down through the lumen, really maximizing digestion and absorption. What does the absorption? The fuzzies, those are the villi, and those are for surface area. I just want you to have a general sense that plicae really allow you to mix it without having to jump up and down and move the material traversing your intestinal lumen. All right. Keep on going. What's this structure? Brunner's glands? Yep. All these purple dots are lymphocytes. Even lymph nodes linked together here. So you know that's a Peyer's patch. Always make sure you get a good one in the field. Tells you where you're at. Peyer's patch equals ileum. This is the lymphatic tissue or the tonsils of the ileum. These villi, but they're fragmented. Once again, third dimension allows you to figure that out.